Hello and welcome to this video looking at question 3 on the compare atomic structure walking talking mock. So a much simpler question here in terms of the space it takes up. So compare protons, neutrons and electrons. So it is a compare question, and I know we're only doing compare questions today, but it's a good routine to get into, a good habit to get into, to always circle, remember, circle, underline, bullet, cub. Circle the command word. Just by doing that, you're telling your brain, this is a compare question, I'm going to have to do something different. And the process of taking that moment to circle the compare word means that you're already thinking, your brain will be thinking, right, what do I need to do for a compare question specifically? Over the next few weeks, we're going to look at different types of command word. Okay, so I know right now this is the only word we've got, but it's a good habit to get into, so please make sure you do that. So compare protons, neutrons and electrons. Right, what do we know about protons? We know they're positive, we know neutrons are neutral, we know electrons are negative. It's worth 4 marks. Okay, so there's 4 things. So first thing we do is we draw our bullet points. So 1, 2, 3, 4. By drawing those 4 bullet points, I'm going to make sure that I give my brain time to start thinking about the answers. Okay, so let's just draw a really simple atom over here, just so we're clear on what these things are. So let's draw a helium atom, and a helium atom is, it's just helium is 2, 4. That tells me it's got 4 things in the nucleus, an atomic mass of 4, 1, 2, 3, 4, of which 2 of them are protons, so 1 and 2. If there are 2 protons, there must be 2 electrons racing around the outside in orbit, and we know the orbit shells are 2, 8, 8. So there's 2 on the first orbital, the first orbit there. Okay. Right. So we're comparing protons, neutrons, and electrons. We're not talking about where they are. We're comparing the actual things themselves. So what do we know? Well, we know that protons and neutrons are inside the nucleus. Protons and neutrons are in nucleus. Okay, that's the first thing. Now, I haven't mentioned anything about electrons, and I have to make sure that there is some element, remember, of comparison in every single sentence I write. Protons and neutrons are in the nucleus. Electrons are not. Okay, that's fine. I could say electrons orbit, that's fine, but I'm just saying for now electrons are not. Protons and neutrons have a mass of 1. Electrons have mass of almost 0. Be really careful here, do not say that electrons have a mass of 0. They do have a mass, it's just very, very small or negligible. Okay, I could have written this sentence instead, saying protons and neutrons have the same mass, electrons have a much smaller mass. That would be fine as well, that would still be a comparison. Okay, if you can't remember that they've got a mass of 1, that's fine. But protons and neutrons have a larger mass than electrons, would probably get you the mark as well. What else do I know? Well, I know they've got charges. I know protons have a charge of +1. Electron have charge of -1. And neutrons have no charge. Okay, which again is a very a complicated way possibly of writing this answer. I could have said protons and electrons are charged, neutrons are not, and that would have got me the mark as well. Okay, I'm just showing off here a bit, writing a slightly more complicated answer I suppose than I need to, but you need to know, it's a fundamental of science, you need to know protons have a charge of +1, electrons have a charge of -1, okay, and neutrons have no charge at all. So I'm looking for one more thing now, one more thing that's different between protons, neutrons and electrons. I've said the protons and neutrons in the nucleus, the electrons are not. I've not really said what the electrons do. So let me write that as my last one. So electrons orbit the nucleus, protons and neutrons stay in the nucleus. Okay, so I've got the idea that orbit suggests movement, whereas staying in the nucleus suggests no movement. So I've written there sort of 4 ideal answers, I suppose, but really you could have shortened these quite a lot. You could have said protons and neutrons are heavier than electrons. That's a comparison. Protons and electrons have charge, neutrons don't. Again, yeah, but if we can get into the habit of saying, we remember that protons are +1, electrons -1, and their masses, everything inside that nucleus has got a mass of 1. So the neutrons and protons, the electrons have a negligible mass around the outside. Okay, hope that was useful. See you soon.